All good. So hello and welcome everybody to our NFDI ToolTalk that is hosted again today by NFDI for Inc. And it is my pleasure to welcome Kob. She's a researcher and computer scientist at the German Aerospace Center at the Institute of Data Science and holds a PhD degree in computer engineering. And she's particularly interested in smart system technology such as Internet of Things and Industry 4.0, as well as semantic technologies. So today she's going to introduce to us a tool that is improving the ontology document and datasheets annotation tool. So please, the stage is yours.
Thank you, Elena, for the introduction. And yeah, as she already introduced, this is going to be a talk about the tool for annotating the documents and also datasheets, but also on the other hand, help improving ontologies. And in a few minutes, I will show you how it can do this. And this project is a part of an OntoHuman project, which is an NFDI for Inc. seed grant project. And before we going into the content itself, so let me do some advertisement about my institute. So if you never heard of, this is DLR is a German aerospace center, which is focusing on the research part and also do the German space agency and also work for a project management agency. And for the research part, we have many focus like aeronautics, space, energy, transport, security, and also digitalization. And as my institute name suggested, is data science, which is dealing directly with the digitalization part. And in Jena, the Data Science Institute in Jena, we have 3 different departments, which are data management and enrichment. And my research group, information extraction and interoperability, is in here. And then we also have the data analysis and intelligence and data acquisition and mobilization departments as well. So now let me describe a little bit about the motivation about this project. So the project OntoHuman happens because we are working together with the engineers, the space engineers who are designing a spacecraft. And in order to do such things, we are using computer modeling tool. And you can imagine that it's a big, huge system. So in order to simulate and to summarize all the parts together, then we need to provide the components and connect each components together. And we have to input like parameters, the details of the device, like width, dimension, or energy consumption, and so on. And this information does not just appear from the air. We need to look into the data sheets, to the documents that describe each component. As we can imagine, there are plenty of manufacturers who provide this information for us. And the engineers has to read through all these specifications, documents, and find the right part. And if it doesn't fit, they have to redo the process again. And you can imagine this is not only time consuming, but also error prone. So we think about why don't we just provide everything in digital format? So the modeling tool can grab this information directly from the manufacturers. But the problem is we already have the space engineering system for several decades, and there are plenty of instruments or devices that has been available, and they have been described within the data documents format that is not 100% digitalized. So we would like to automate the process of reading data sheets. So just grab the PDF files and then we try to do the extraction process for you, and then combined with some plugins or API, the modeling tool can grab this information from us. So that's the idea. And talking about automatically reading data sheets, you can think about the natural language processing. So maybe we can just apply the NLP process on those part of documents, but that's not so easy because we still need to get to link the information within documents with the external knowledge base. And that's to make an understanding in the context of documents or what has been written down in the documents. Like in the domain of engineering, when you specify a battery, maybe you know by your heart already that we should look for the mass, power consumption power, the parameters of the batteries, what do we need to know about them. But the machine does not know about that. So we need to combine the semantic knowledge from outside, which could be described in form of the ontology to our process. And if you are not familiar with the term ontology, this is the technology that describe things in the real world or concepts in the real world in the digital format. So you can specify the relationships between two objects, or you can also describe the attributes of each object. Together with some rules, some restrictions, like these objects should not contain multiple mass or multiple dimension. It should have only one size, something like that. And to give you a clearer picture how it look like, the ontology can be described or can be represented in many ways, but one of the popular way is to describe it, to show it in the graph node formats like this. And here is the example. So if I want to describe a device called a star tracker, I would provide the information like a star tracker should consist of the attitude accuracy, field of view, signal to noise ratio, and so on. And maybe I would add some information like the field of view should be provided as a text format. So you can imagine we have the field of view and we are looking for something that comes after or before the field of view that is described in text format, and we want only one value that is corresponding to the field of view, something like this. So the machine, when it reads this ontology, it can understand what kind of information it should look for if they are looking at the document of describing a star tracker. So we have the information extraction, we have the ontology, and these two things should work together. And how come the human into the process, which is the why we name this project as OntoHuman. So it looks, the whole process is looking like this. You have the documents, and first we just extract all the keywords out of the text. It doesn't matter which keyword it is, but the machine would not understand the context of these documents. So if it finds the word space, the term space seems to be important in this document, but without the context, the machine could not understand which definition, the correct definition of this space. Maybe it's a space in architectural text or in space engineering text, which has totally different meaning. So we use the VSM or vector space model to disambiguate this definition. And with the correct definition, then we can look out for the external knowledge base like Wikidata or the WordNet to find more related informations, like if it can be called in what term in other languages, or if a battery should consist of which parameters. So this is how we extract the external knowledge. And then we can combine this, accumulate this information to the existing ontology that we have from the beginning. And finally, this extended version or enriched version of ontology can be used by the information extractor to look for specific terms within the documents. So in the beginning, we just extract everything, but later we look for more specific terms. And this whole process should not be done totally automatically. We require some reviewers in between, just to make sure that the ontology is not getting wrong or misleaded to the wrong concepts. And before we getting into the demo part, let me describe how the whole system are put together. So what I described before can be depicted in this overview image. So the main modules in in this project is the DSAT or Datasheets annotation tool, which is going to be demonstrated in a few minutes, and the information extraction part. And then the backend, another backend is continuously trained ontology, or we call contron. Contron is dealing directly with the ontology, with the process of enriched or improve the ontologies. And in the meantime, the contron can also extract the information like synonyms, related terms from ontologies, and feed this into the information extraction, so that information extraction part can really look for specific things in the datasheets or documents. And at the end, DSAT would provide this, would display this to the human user, which means DSAT should be intuitive enough so that the user can understand what kind of information has been detected, and they can also give the feedback back to the backend system that maybe this is wrong. And then if something's wrong occur, then the maintainer of the ontology will get the report from the DSAT. And at the end, they can also help improving the ontology. And this is the rough interface, the screenshot of DSAT. So before I show you the demo, the live demo, on top of the tool, you can see the selection of datasheets, and you can change the metadata of datasheets. You can upload your own datasheets as well. And on the left-hand side, you see the view, the preview of your document. You can highlight the text here to annotate the data, which is specified as a key, a value. And you can edit, come back to your document later and edit each annotation. And you have like summarize of all the annotations that you had made before in the table below on the right side. And yeah, I would show you how it works in the live demo, but just keep in mind that this is also important that we provide an interface for the end user to give us the feedback if they think the information that has been automatically detected is wrong, and why it is wrong. Is it because the ontology misplaced it, or is totally the wrong concept? Okay, so I think we are on time, and I can switch to the browser. So DSAT is developed as a web-based tool. So you can, at the end of the project, it will be provided as an open source code. One can build the code and deploy it on your local machine or virtual machine and run it as a web service. And due to some, I would really love that everyone can also try it out and give me the feedback, but due to some data restriction, I can only show it here as the internal, on the internal server. But if you are interested in trying the tool, please contact me directly, and I can also try to provide something in only a few minutes, and you can try it out from your side. Okay, so let's come back to the tool. First, once you land on the landing page, you would see the sample data sheets looking like this. And this is like only to exemplify how the tool is looking like. And you can do some basic things like doing a manual annotations. But of course, this is not really useful because you cannot really save it to the server, and it's only limited to these sample data sheets. You cannot upload your own data. So I suggest that first we should log in with a specific with a unique username. I was logged in before, so let me log out first. And with this sign in, there's no real registration required because we just need to keep the track of progress, of work in progress. So basically, you just provide your unique username there. And once you are logged on, you will be able to see and to upload your own documents. And because this is designed to be a cooperative tool. So in the beginning, we let all the users see the uploaded data, the uploaded documents. So once you upload your file, then your colleagues can also, or the other users can also see the same files. This is due to we would like to have more than one opinions for one users. But the annotations that you made on a particular document cannot be shared. So it still belongs and still be visible only to the user who created that. And let me show the first existed or the one that I uploaded before. So this is the one that I had worked on before. And I can clear up all the previous annotations and show you how to work with that. And don't worry, in the next version, it's going to be clear all features, which is coming soon. And first, I suggest that you can either manually highlight data and then identify it as, specify it as a key and value, just to make it clear what is the keyword and the corresponding value. And in some case, you might want to have one keyword with different values. In this case, I would suggest that you do the annotation first and then duplicate it and edit the second one by changing the corresponding value. And that's why we want to have this duplication feature. And if you don't like, you can also delete that later. And when we, as I promised in the beginning, that we would like to have the automation process of annotation. So we don't want our engineers to highlight everything here, but rather be able to do the auto detection. And you can also specify the number of pages you want to extract the data. In case that you have 100 pages of documents, then you don't have to wait for too long time. And it also depends on how big your ontology is. If your ontology consists of a lot of classes, a lot of information, then it takes more time to process the whole document because it keeps looking for every single keywords that has been specified there. And this is the result. So you can see that some of the information are still missing, like the discharge or vibe levels. And this is due to the incompleteness of the ontology. So within the battery ontology, we don't have those terms specified. And this is why we want the user also be able to manually annotate the data so that we can collect this information and continuously improve the ontology on the back end. And of course, you can save your progress to the database, or you can either save to the database or save the progress to your local machine for later usage. And this will be saved in the JSON format if you would like to download it to you locally. And okay, it's better that you save your change before you move to another document. But at this point, I would like to show you something else, like adding new datasheet. And I would like to emphasize the importance of the ontology. So in this case, I consider that my document belongs to the CubeSat domain, this is important because the category of the document would specify which ontology the backend system is going to use for the automatic extraction. And I just run the auto detection with the understanding of that this document is a CubeSat description. But you might have noticed that this is not actually, it is a description of solar panels, not a CubeSat. But I will show you the difference if you specify it as a CubeSat or solar panels. So as a CubeSat, the efficiency, the power, voltage, and so on, mass, size, these are the general information that CubeSat is required. But the information like sales, protection, substrate, this is unknown to CubeSat. This is why we need to specify the right ontology so that we can use the full features of the auto detection. And in this case, I just prepare my solar cell ontology. And then we do the auto detection again to see if the result is getting better. So this time, most of the things are similar as before, but now we have the protection cells, interconnects, and substrate detected. So this is why we need to choose the right ontology for the right type of document so that the machine can understand which information they should really look for. So this is the main thing I would like to show, and talking about what could be the next step. Yeah, first thing is that I would like to have a better representation of the ontology here. So this is like doing some kind of blind date, because you cannot really, you see that, okay, this is an ontology of GNSS receiver, but what else? So I would really like to have a preview of the ontology, maybe in a graph representations together with the metadata of the ontology itself, just to make the user have a better understanding what kind of ontology they are dealing with. And as well as the other type of information that previously we are talking only about the textual information. Yeah, we have the text maybe in the table or described in the bullet points, having key and corresponding values. But how about the information like graph? This could be very interesting for some engineers, because this is definitely need human to interpret the data. And oftentimes you cannot interpret it correctly because you need a ruler and good eyes for that. So it's I think it's also interesting to have such information extraction from plotted graphs, so that you have more detailed data points on your the results of information extraction. So those are the main things that I really love to demo in the next release or by the end of the project. And other than that, I also got, we had the workshop, the second workshop in the middle of the project just last week. And I got a lot of fruitful information, like we need some kind of help and user guide for the first time users, and some small improvement in the user interface. And anyway, these are still being open for more suggestion and idea, and I would really love to get the feedback from everyone, and also offer you if you really want to try the tools directly. And these are some list of publications that we already talk about the idea behind Contron, behind the OntoHuman. So, and that's it. And any questions are welcome. And also one more thing, if you are not comfortable to ask a question here, you can also go to this survey and help me give the feedback of what do you think about the tool and what else do you want to have. Okay, thank you for your attention.
Thank you very much, Kob, for this very interesting insights. Now, if you have any questions, you can just raise your hand or write in the chat. And in the meanwhile, I'm going to